Some GRE math questions will express English in math. You'll see something like if 4 more than the product of x and y is 3 less than the sum of y and z, and what you have to do is translate that English into math in order to solve it. The good news is there's only a few basic terms that you need to translate between English and math. This question says, if 6 more than x is 2 less than y, what is the value of y in terms of x? So it's a multiple choice question, and I can take this English language expression and convert it into algebra. I need 6 more than x. Now notice that's not 6 is more than x. It says 6 more than x. So what I'm going to do is take x and just add 6 to it. This is x. This is 6 more than x. And it says is, and is just another way of saying equals 2 less than y. So it's not y, it's 2 less than that. And this is confusing. Sometimes you're thinking, okay, 2 less than y, which is actually this is 2 is less than y. Or you might be thinking 2 minus y. And the easy way to test this is to just try a number, something like 10. What's 2 less than 10? 8. So what am I doing? I'm taking my y, my 10, and subtracting 2. So now I have this written in a simple algebraic expression, and it's asking for the value of y. So to solve this, all I'm going to do is add 2 to both sides. When I do, I'm going to get x plus 8 equals y. So what is y in terms of x? Well, the correct answer to this question is just going to be e. These are some of the common English words and their translation into math. And you'll notice that they translate into pretty basic operations: addition, subtraction, multiplication, and division. So if I say something is more than something else, well, then I'm adding to it. If I say something's less than something else, I'm subtracting. If I talk about something being times something else or of something else, that's multiplication. And if I'm calculating the quotient or taking one thing per another, then all I'm doing is division. Now let's see how this applies on another question. This question says, Beth is 2 years older than Debbie and 4 years younger than Marnie. If Debbie is D years old, how old is Marnie in terms of D? So it's a multiple choice question. And I see that there are a couple of different expressions here. It says, Beth is 2 years older than Debbie. So Beth is Debbie plus 2. And you might be tempted to say, well, B plus 2 equals D, but this makes sense. If Beth is 10, then D would have to be 8 in order for this to be true. So Beth is the older one. In the next expression, it says 4 years younger than Marnie. Well, who's 4 years younger than Marnie? It's actually Beth again. This is kind of confusing. It says Beth is 2 years older than Debbie, and kind of parentheses, Beth is 4 years younger than Marnie. So Beth is Marnie, but 4 years younger than that. And again, real numbers make this even clearer. If I say Beth is 10, Marnie would be 14. And in that case, Beth is 4 years younger. So now I have 2 different equations with 3 different variables, and I need to relate M and D, Marnie and Debbie. So I need to get rid of the B's. And the easiest way to do this is, since both equations are equal to B, I can just set these equal to each other. I can take the D plus 2, which is another way of saying B, and set that equal to M minus 4, which is another way of saying B. So now what I need to do is solve for Marnie in terms of D. And to do that, I'm going to add 4 to both sides, and I'll get D plus 6 equals M. So what is Marnie in terms of D? The correct answer is C. Now you almost couldn't come up with a better case for why plugging in is such a great strategy, right? I've got 2 different equations, 3 different variables. I had to set them equal to each other, solve for one in terms of the other. It would have just been easier to take these variables and replace them with numbers from the beginning. Just say B is 10, D is 8, and M is 14, and work it through. So whenever you see variables in the answer choices, try plugging in.